Today we are beginning and finishing 8.3. So it's another section based on geometry. So here we have A, B, C, D, E, and J, K, L, and M are similar. Now, when we say that two shapes are similar, that means two things. It means the angles in one shape exactly correspond with the angles in the other shape. Okay, they are congruent. And when we list this, we have to list those letters very carefully. When we say A, B, C, D, E, and J, K, L, M, N, we mean that A and J are congruent. Right? So you have to list them in an order so that the angles on the first one match up with the angles on the second one. Okay? So that's the first part of similarity. The angles are congruent. Right? It doesn't mean A and B are the same, but it means that A and J are congruent. Also, all of the sides are proportional. So if the second figure is twice as big as the first figure, then DE times 2 will be MN. And we say those are proportional. So if you take any side on one shape and you divide it by the corresponding side on the other shape, you're going to get the same ratio. So if you go from big to small, the ratio might be 2. But if you go from small to big, the ratio could be 2. But going the other direction, the ratio would be 1/2, 1/2. Okay, so what is the ratio here? Well, we want to find what x is, this side right here. So we pick any side, it doesn't matter. And I like to do big side divided by little side. So 8 divided by 5 is going to be 1.6. So if I pull up, oh, my calculator's not on. Let's make this a little bit bigger. All right. So 8 divided by 5 is 1.6. Now that should be true of any side. So if I take JK and divide it by AB, 4.8 divided by 3, I should get 1.6. And that's true for every single side. If one of the sides does not give the same ratio, then the figure is not similar, which is equivalent of saying if one of the angles is not congruent to its corresponding angle, then the shapes are not similar. So if I know that DE is 2, how am I going to find the length of MN? How do we go from small figure to big figure? Well, we multiply by this ratio here, 1.6. So 2 times 1.6. So MN must be 3.2. Okay, let's look at another one. All right, we are told that the shapes are similar. We want to find the length of QR. So QR is this little one here. So we need to take any side in the big figure and divide it by its corresponding side in the little figure. So I'm going to do 4 divided by 2.4. So 4 divided by 2.4. And I get a ratio of 1.6 repeating, which if I turn that into a fraction, it's going to be 5/3. Okay? So if CB is 2 and my ratio is 1.66666, how do I turn 2 into this number? So am I going to times it by 1.6666 or divide it by 1.666? Divide, how come? I'm going big to small. So the ratio, 1.6, is from small to big. So I'm going to take 2 and divide it. How do you divide a fraction? You have to put it in parentheses. So that turns 5/3 into its own number. And I'm going to get 1.2. Now, can I use the decimal? Could I just do 2 divided by 1.66? No, it's going to be off by a little bit. Okay, but if you did 2 divided by 1 point and you did a whole bunch of 6s, at least if you did this many 6s at least or more, then the calculator is going to give you 1.2. So it's just kind of a little trick. If you fill the screen with 6s, then you will get the right answer. Does that make sense? Do you need to see any more of those? No? Okay. All right. Similar triangles. Okay. How do you know if two triangles are similar? If all three angles match up. But do you actually need to know all three angles? No. You only need to know 2. Why is having 2 angles enough? Yeah, so here we have a right angle and a right angle. And this angle are vertical. So this angle equals this angle. Does that guarantee that this angle equals this angle? Yes, it does, because of the triangle angle sum. So we know that these triangles are similar. So we have hypotenuse, we have short leg, and we have long leg. Right? So I know that the short legs are proportional, the long legs are proportional, and the hypotenuses are similar, are proportional. So what is the ratio? Well, we take big divided by small. 5 divided by 4 is 1.25. So the ratio from small to big is 1.25. So what do I do to 2 to find x? Times it by 1.25 because we're going from small to big. So in my calculator, we just do 2 times 1.25, and we get 2.5. Okay. Same thing here. This is going to be, no, it's not the same answer. Yes, it is. So small to big, 5 divided by 4 is 1.25. So 2 times 1.25, it's going to be the exact same answer. Okay. So here we have short leg, short leg, long leg. And we have hypotenuse and hypotenuse. So 6 divided by 4.5. 6 divided by 4.5 tells me that the ratio is 1.3 repeating. So if I want to go from small hypotenuse to big hypotenuse, am I going to multiply or divide? Multiply. So we're going to do 6 times 1 point, a whole bunch of 3's. What if you don't put enough 3's? So let's say I don't quite put enough 3's. You should be able to tell what it is going to be. So what do you think the answer is? Do you think it's actually 7.999998? It's 8. So if I did more 3's, let's do 1 extra 3. Okay, let's do another extra 3. And it won't take the same number every time, it just kind of depends. But you guys can see where we're headed, right? And eventually it's just going to, well, eventually it will give up. Maybe. I'm going to get there. Yay. All right. So let's go to the next problem. All right. We have our Mona Lisa. Each centimeter in this picture is equal to 9 inches in the original picture. So in the scale drawing, the length of the painting is 6 centimeters. So from here to here is 6 centimeters. So how big is the length of the original drawing? You would multiply it by 9 and turn it into inches. So 6 times 9 would be 54 inches. If the height of the original painting is 36 inches, how big is the scale drawing? Would be 36 divided by 9 is going to be 4 centimeters. Okay. So a scale drawing for a plot of land is shown below. In the drawing, 2 centimeters equals 3 meters in the real land. So assuming the backyard is rectangular, what is the area of the backyard? So we would change 8 centimeters. What would 8 become? It's a little bit tricky. Why is this one tricky? It would be 3 times 4. Where did you get the 4? We have to take 8 centimeters and divide it by 2, and then times it by 3. So 8 divided by 2 is 4, times 3 is 12. What about this one? It would be 4 divided by 2, which is 2, times 3 is 6. So 12 meters times 6 meters would be 72 meters squared. So the backyard would be 72 meters squared. That's I guess for an apartment, that's not bad, but I would struggle with a backyard that small. Where would all my junk go? All right. Okay. So here we have a sculpture and a model of that sculpture. And the length of the sculpture is 27, the model is 6. The width is 18, the model is 4. The height is 54, and the model is 12. How are we going to find the scale factor? So, yeah, so is it 6 over 27 or is it 27 over 6? And why is it 6 over 27? This says, find the scale factor of the model to the real structure. Okay, so how big is the model compared to the real structure? Well, is the model bigger or smaller? The model is smaller, so we need to do 6 divided by 27, and we end up with 1/9, which is 0.999999. Okay. Oh, it's not. It's it's 0.111111. I got it backwards in my head. Okay. Lastly, a pair of similar figures is shown below. Sides C and CD and EF are corresponding. Use the information to find the area. So the scale factor is 9 over 5. So let's calculate that. So 9 divided by 5. So the scale factor is 1.8. Okay, so let's work on the perimeter. If the perimeter of the big is 36, how do we find the perimeter of the small? Divide by 1.8. So we're going to take 36 and divide it by 1.8. So the perimeter is 20. That's the easy one. What about the area? So this figure is 1.8 times bigger than this one. So can I take 75 and times it by 1.8? What do you guys think? Well, what if it was, let's say it was a rectangle. Okay, so let's say we have a little rectangle and a big rectangle. And this is a 1, and this is 1.8. Right? So let's say this is 2. So this would be 3.6. Right? Okay, now watch this. Some of you aren't paying attention. This is critical. The area of this is 1 times 2, which is 2. The area of this one is 1.8 times 3.6, which is 6.48. Is 6.48 1.8 times bigger than 2? No, it's not. Why not? And the answer is you have 1.8 in this direction and you have 1.8 in this direction. So how much bigger is this going to be from 2? It's going to be 1.8 times 1.8 because there are 2 directions. So to go from 75 to this, I'm actually going to do 75 times 1.8 times 1.8, and I get 243. I think. Should we check? Let's try it. Let's see how good I am. So 243, and this one was 36 divided by 1.8 was 20. Yay! So if you are dealing with one direction, not the band, I know you guys love them, then you just times by 1.8. But if you're dealing with an area, you're dealing with 2 directions, an x direction and a y direction. So you need to do 1.8 times 1.8. What if we were dealing with some kind of solid figure, 3-dimensional figure? Then you would times by 1.8 times 1.8 times 1.8. Okay, that's it. Get to work.